Okay, I'm making the assumption here that the definition, that this really should say using the definition of derivative at the given point when x equals 1. Okay, so this is the definition of derivative right here, or at least it's one of the forms for the definition. So for our function, we want f prime of x to equal the limit as h approaches 0 of f of x plus h. And I've shown you how I calculated that up here. In the definition of this function, x is like a template, and I'm putting x plus h in there. So there's f of x plus h minus f of x all over h. And I want the limit of that as h approaches 0. Now, the easiest way to simplify this expression is to multiply numerator and denominator of the big fraction by the common denominator, or the least common denominator of all the little denominators. That's these denominators right here. And what that does is turn this into a simple fraction. So when I take x plus h minus 4 times the first term in the numerator, these cancel out, and I get 3 times the quantity x minus 4. Then when I take this LCD times the second term in the numerator, the x minus 4s cancel out, and I get minus 3 times the other factor, x plus h minus 4. And in the denominator, I've got h times the multiplication by the LCD. Forgot the right parentheses there. Now, when you simplify the numerator, I'll let you do that. You distribute this 3, distribute the minus 3, collect similar terms, combine similar terms, and it simplifies to negative 3h. And the whole point is the h in the numerator cancels with the h in the denominator. And now I can actually take the limit by substituting 0 for h. I don't get 0 in the denominator, so I've got it. There's a formula for slopes of tangent lines to this original function, 3 over x minus 4. So to write the equation of the tangent line, I need to find a point that the line passes through. And I know that the x-coordinate of that point is 1. So I'm going to find f of 1 to get the y-coordinate, which is negative 1. And then I'm going to find f prime of 1 to get the slope of the line at that point. And that will give me negative 1/3, which is equivalent to m when I use point slope. So here's the equation of the tangent line right here in point slope form. You could simplify that or put it in slope intercept form. But where did this come from? It's y minus the y-coordinate of the point. Y minus a minus 1 is y plus 1 equals the slope, negative 1/3, times the quantity x minus x of 1. And there's the x of 1 right here. So here's what the tangent line looks like on a graphing calculator. The red curve is the equation, or the graph, I should say, of the function 3 over the quantity x minus 4. And this is the tangent line at the point where x equals 1, which is the point 1, negative 1. Okay, hope that helped. If you have any questions, post a comment.